In this video, we will try to understand Azure Route Server. To understand Azure Route Server, to know what it is, why we use it, let's go through a simple scenario. This will help us to put it in perspective. So, today's topic is Azure Route Server. All right, let's assume a scenario where we have this simple Azure Virtual Network. Let's make it blue. And we have hybrid kind of uh, setup. So we have Azure Virtual Network in blue. And now it's a hybrid environment. As I said, we have on-premises environment right here. This is our on-premises environment. Now, Azure Virtual Network has NVAs in place. These are NVAs, two NVAs for high availability. Okay, NVA. And in on-premises, we have something called router. Okay. On-premises also has some branches. Okay, let me add some branches here. And these branches are connected with the on-premises environment. And on-premises environment is connected with our Azure environment through a VPN, tunnel, or express route. Express route or VPN, or maybe both for redundancy. So this is a simple setup that you will see quite enough in your daily work experience when you work for the cloud organization or MSP. All right, now the scenario is at this point in time, everything is configured manually. The information of on-premises, IP address, range, CIDR rules, everything is done here and everything is fine. Till now, everything is fine. But what if the IPs are changing frequently? For example, this on-premises starts opening new stores. Okay, right now when the setup happens, there were 3 branches. Let's suppose this create 2 more branches, which means 2 more side ranges, right? And these NVAs are not aware of these side ranges and it will drop the traffic until you do that manually. Go and update the routing tables, provide the information what all changes are happening. Okay, that's the first challenge. Second is some routers experience periodic IP changes due to ISP policies. So that could be the challenge. All right. Now let's suppose in the same ISP changes. I'm giving an example just to put it in perspective. Let's suppose a branch of its router's public IP changes from XYZ to ABC due to an ISP upgrade. Now, NVAs and Azure Virtual Network using static routes fail to recognize this change, breaking the connection until the static routes manually updated because everything is happening manually here. All right, now let's take another example, which I was talking about, which is if these route an organization starts with 3 branches, each with /24 subnet. Over a year, it grows up to 20 branches or 20 unique subnets. So what will network engineers must do? Uh, Add and manage 17 new static routes in the NVAs. This will, of course, increase the likelihood of errors and misconfigurations, but that is something that's supposed to be done. Now, if express route circuit goes down, traffic must manually be rerouted through the site-to-site VPN connection. This delay in reconfiguration can cause outages for critical workloads. And NVA configured the static routes only knows about the uh, one particular range of IP addresses, and whatever changes is happening in networking from the other side, NVAs are not aware. Okay, NVAs are not aware, and to make them aware, we need to update it manually. That's the crux. Okay, and now suppose a routing table has 50 entries or huge number of entries and a typo in one route instead of uh, you know automatic. If we are doing manually, the typo in any one route result in lost connectivity for an entire branch. All right, so if we need to just summarize all the examples I've given, any changes is happening here, we need to do manually here, right? So what is the challenge here? Changes in network could be the private subnet or public IP, right? Or VPN express route. So any changes in network we are doing here manually needs to be updated to stop the disruption. Update routing table, right? Which leads to error, delay, time, etc., etc. So what is the solution for this scenario, this kind of scenarios? Solution is simple. Company will deploy a dedicated subnet for Azure Route Server. Okay, that is the topic. That's what we are going to learn. So this is Azure Route Server. This will solve the problem. And how this will problem solve the problem? Because ARS supports BGP, okay, and on-premises routers going to advertise the changes in network. This router will going to advertise to Azure Route Server through BGP. Advertise via BGP to Azure Route Server. Now, once Azure Route Server is aware of these changes, this will propagate these routes dynamically to NVAs. Now, this thing is happening dynamically, automated, dynamically to NVAs, to the NVAs. Now, when a new store or new branch, let me write it down here, branch. When a new store or new branch added with another /24, the on-prem router advertise this subnet to Azure Route Server, which automatically updates the NVAs. So that's how we are solving this problem. Similarly, if any of the routers IP changes, BGP updates those things here in the ARS, and same process goes on. So what is ARS now? Because now we know what it is doing, and now we can define what is ARS. So let's define what is ARS. ARS is, the very first of all, we need to understand it is managed service. Okay, you are not deploying a virtual machine, you are deploying a service. It is a managed service, and what it does, it allows uh, dynamic exchange routes between your network or Azure Virtual Network and any other network, like in our case it's on premises. So dynamically exchange routes. Okay. between networks. So what it is doing, it is simplifies the integration. Simplifies the integration. No need to do a lot of manual updates on the route table, but it will take care automatically, right? Especially when you're using NVAs or firewalls, which does not support BGP by default. So ARS or Azure Route Server can help you do all those kind of integration or dynamic exchange of routes. And it will save a lot of time, efforts, and less error prone. And it is managed service, so it has all those wonderful features like high availability, scaling capability, etc., that we'll see. Uh, Now, if we have understood this scenario, I hope you can give me the answer. Let me call it what? Okay. Why we need Azure Route Server? Okay. So you need to answer me this. Why we need Azure Route Server? All right. Keep digging your mind. If you're thinking the way we have explained the scenario, you will have all the answers. For example, in our complex hybrid networking scenarios, maintaining static routing configuration is error prone. So, static routing is error prone. If it is static, it is time consuming as well, right? And difficult to scale for sure, right? And what else? Well, you need to be aware and present. That means complex management. So all these problems will be resolved if we are using ARS, Azure Route Server, because it will exchange the routes dynamically through BGP if it is happening automatic. So time will be saved, and it is managed service. So by default, it gives you scalability, and it's simplified management as well. So that's why we should use it in the scenarios where NVAs and firewalls and complex network topology is involved. And this is something that we should be aware of. This is why. This is what. Now we are learning Azure Route Server step by step. With this scenario, it helps us to grasp the need. And now we defined what it is and why we use it. Now simply go ahead and check some key features. Key features of ARS. So what are the key features? The very first thing is it supports BGP. And why we need this? So that they can exchange the route. That's the protocol by which it can happen. It enables seamless route exchange between NVAs and on-premises routers. Second is because it is a managed service, so route service is deployed in pairs in Azure, like gateway virtual machine pairs to ensure fault tolerance or high availability. Now, this is managed service, so ease of use automatically integrates with your Azure Virtual Network route tables, dynamically do this stuff. Then scalability, because it adapts to change in network topology without manual intervention, and it is managed service. Now, it is one place, so it has centralized management, simplifies routing management by acting as the central point for dynamic route exchange. And of course, error reduction. It eliminates manual updates, reducing the risk of misconfigurations and connectivity issues. So these are some key features that we get when we use ARS or Azure Route Server. All these are the key features. All are connected to each other. If you understood this scenario, you can answer what, why, the features, and everything, right? All connected to each other. Now, let's quickly check how to deploy this route server. Let's go to route server. It's very simple to deploy. The only thing that we need, we already have one deployed. Now let me just show you. We'll dig route server here. We need to give the resource group. We need to give it a name, location, routing preference, and that's all. And the virtual network, in which virtual network you want to deploy it. It also needs its own public IP address and dedicated subnet. For example, if I select this, it says it must contain subnet with the name route server subnet, just like firewall and gateway, or with /27. So once you apply these simple settings here and click on review and create, you would have the route servers. I have one route server here. Once it is created, it looks like this. And it takes a lot of time, 10 to 20 minutes. And this is all information that we have. Under peer, we can add the peers. Now, the things that we should be aware of for this deployment, the very first thing is we should, let me write it down for you, deploy the things that we should be aware of during the deployment of this route server. The first thing is Azure region. We should know whether the service available there or not, or are we deploying the correct region. We need to identify the virtual network, and the subnet is required. Dedicated subnet is required with its name. And when we create this, Azure can simply create when we justify like why we are creating this subnet, then it will automatically does that. For example, if I go here under home, go to virtual networks, if I go to this virtual network and go to subnet and try to create subnet, and if I select subnet purpose, if it is a route server, it will automatically create the route server subnet with this name, dedicated subnet, right? And with the size of /27. Now, once it is, these things are configured, you need to give it a name, right? And once it is deployed under the peering that I showed you, you need to establish BGP sessions between Azure Route Server and your network like NVA or on-premises, specify the ASN, which is autonomous system number, and BGP peer IPs for the device you are connecting. So these are the simple things that we need to do when we deploy this ARS, nothing big. But from the perspective of design, when you're deploying ARS, there are certain things that we need to keep in mind. Let's go with those things with a different color so that we are aware we are talking design consideration. So if this is the ARS that we are deploying, the very first consideration is what? If your guess is Azure Route Server subnet, a dedicated subnet with /27 at least, you are correct. Ensure subnet size accommodates future scaling needs as well. It depends how complex is your environment. The second consideration that you must have in your mind is if you have any manual updates prior and you have added ARS, which updates routes dynamically, so you need to monitor conflicts. Monitor conflicts. Okay, with manual configuration, configured routes, if there are any. Then you need to ensure ASN configuration for route server and peers do not conflict, right? So we need to use different ASN for Azure Route Server and or NVAs like here, right? That is our third point. So I should write here. Third is uh, different ASNs, no conflicts required. Now this ARS, this is deployed in the pair of virtual machines for the high availability and fault tolerance. So you need to ensure your NVA supports redundant BGP sessions, because ultimately these pair of VMs are what they're doing. They are receiving information from on-premises propagating to the NVA. There is an integration, so all those integrated resources must be compatible, right? Now, if because this is managed services, so you need to plan for route capacity, because Azure Route Server supports how many routes as we are propagating here? Yeah, 1,000 routes, okay? And you need to consider subnet expansion if your topology grows so that it can cater all those easily. Now, all those information coming from on-premises to ARS, and if you're you need to be sure because it is happening through a TCP port 179, so your NSG must allow that. So you need to take care of that from the design perspective. Now this propagation, this movement of BGP sessions, these BGP sessions are not encrypted. BGP sessions are not encrypted, and we are working with the enterprise, very big complex enterprise, and we want everything should be encrypted. So use VPN tunnels, which is sending encrypted data. If it is BGP session, that would be encrypted too. So that would be okay. 7, 8. That's fine. All the red one are the points of design consideration. Now we need to be make sure these NVAs supports dynamic routing with BGP. All right. Don't just assume like all the NVAs are capable of doing that. So you need to be aware. For example, region. You must check the region if you're deploying any such service. All right. Apart from that, we can also utilize Azure Monitor. We must, from the design perspective, to track route server health and route changes. We must enable diagnostic logs for audit and troubleshooting. Now, since it is a managed service, and of course, there are some additional costs, so you need to review the pricing and ensure it aligns with the budget, right? Now, there are few scenarios like failover. Test failover for NVAs and on-premises connections will help you validate automatic rerouting of traffic. You should do that before relying on it. And I think that's all about it. That's all about the understanding Azure Route Server with the help of a scenario. We define what it is, why we use it, different key features, and different design considerations. I hope it was useful, and thank you for watching. You guys have a wonderful day.